In the field of science, the huge mysteries pertaining to what was prior to the enormous explosion have sparked mixed conversations and fascinated characters for quite some time. This enormous question tests more than just our ability to decipher the universe. It challenges the genuine, furthest limits of human knowledge. Imagine yourself at the brink of existence, looking into the colossal unknown, observing and pondering the contents that existed before our universe was imagined. The Big Bang, which established the beginning of time, space, and all that we know. But in any case, were you there a moment earlier? In the past, this might have been a state of nothingness, a calm before the cosmic gathering began. And if this is true, was it? Or perhaps was there something far more frightening that existed previously, before time itself? As we continue with this inquiry, we are taken on a journey beyond the limits of science, into insights that test our conscious awareness. Physicist Brian Cox is well known for his examination of the wonder of the universe. He suggests that surprise may have existed prior to the massive explosion, directing us to reconsider our perception of the world and existence. In this examination, we'll dissect the science, the speculation, and the dazzling insider secrets that might figure out what happened before everything else. We'll explore thoughts like self-importance and growth, quantum alterations, dark energy, and multiverse. The answers we've revealed might just paralyze you, but they might also open up new perspectives on our position in the universe. Get ready to dive deep into a realm that defies imagination and science. In the midst of the obscure, among the shadows, scientists are left floored, and sometimes even upset. We ought to investigate the events preceding the Big Bang and the reasons for these theories, which test everything we thought we knew. To appreciate what may have existed before the Big Bang, we must first meticulously examine what the Big Bang was. What is the Big Bang, according to scientists? It refers to the moment when the universe became extremely hot and dense, rapidly expanding to cause the growth of all matter, energy, and space. When we look at the universe, there are no boundaries. The night sky reveals evidence of this hot beginning, with the expansion of galaxies moving away from a single origin point. But for what purpose did this happen? Furthermore, was there a period before this dense, hot start? As indicated by the theory of enormous expansion, there was, without a doubt, something before. Furthermore, it lacked any semblance of void or peacefulness. Vast expansion suggests that the universe existed before the Big Bang, in a state that was cold, vacant, and loose, essentially like an immense vacuum. Anyway, this vacuum wasn't entirely unfulfilled. It contained a tremendous amount of energy that fueled the quick extension of space itself. This extension, called inflation, happened so rapidly that it essentially established the groundwork for all that would follow, a part of subsequent space extending at unfathomable rates until the extension slowed down, transforming energy into matter particles and the forces we recognize as the Big Bang. But what was the nature of this energy? Why did it suddenly grow the universe, and why did it stop? Experts believe that this inestimable expansion created patches of the universe, each with its own set of Big Bangs. Imagine a fabric extending endlessly, with tiny pockets of air forming, each one illustrating a universe, including our own. This thought, called the inflationary multiverse, suggests that there are conceivably endless Big Bangs and an infinite number of universes. Ours is just one of many. This huge, mind-bending reality challenges our understanding of the entire universe, leaving us with the question, what else is out there? The idea of nothingness before the Big Bang is speculative, not real, at any rate, as per our current understanding. Regardless of whether you eliminate all energy, particles, and radiation from the universe, it still wouldn't be genuine void. Our universe is filled with dark matter, quantum fields, and dark energy, forces that weave an inevitable artwork embroidered with something, even in its most vacant form. Even if we imagine stripping away all of these forces, leaving a dead space, the universe would still generate new kinds of energy. This reality is bewildering to specialists, as it suggests that true nothingness might be impossible within our infinite understanding. Space itself has properties, rules, and constants that prevent it from being totally empty. Imagine constructing a region with no particles or radiation, with only quantum fields and major constants. These would still exist, implying that even non-existence has properties. For instance, there's a peculiarity called zero-point energy, which represents the least amount of energy possible in a quantum field. In this state, particles are still able to temporarily appear and evaporate, creating a spooky reverberation of movement, regardless of the fact that it should be empty space. This challenges our idea of a real void and suggests that, indeed, prior to the Big Bang, there was something scientists are only beginning to understand. One of the most astounding theories in current cosmology is the chance of timeless expansion. If inflation could cause our universe to exist, it's possible it could continue forever. Brian Cox describes an astonishingly vast inflationary multiverse, where universes are infinitely created and continue expanding. Imagine each Big Bang as a flash lighting another universe, while different areas continue to experience inflation, making countless other universes. This cycle could, in theory, go on for eternity. This idea of vast universes gives birth to an enchanting concept, the fractal universe, where each new universe might actually create its own Big Bang. Every universe exists as a separate, independent domain, unaffected by the others because of the rapid expansion of space. This hypothesis is both exciting and upsetting for researchers, as it suggests a never-ending multiverse with no predetermined beginning or end. Our universe may be only a marginal component of a gigantic cosmic structure, one that never stops growing and continuously constructs new universes. And what if the upsetting fact is that there is no before or after, but rather a timeless pattern of universes forming and decaying? When we take into consideration quantum field theory, it tells us that the universe is not just an assortment of matter floating in space. Rather, it's a complex network of energy fields that connect everything in the universe. These fields are like invisible seas, with waves or particles acting as disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they are still active. Particles can form and vanish in these areas, briefly acquiring energy before returning it. This phenomenon results in virtual particles, substances that immediately exist and then vanish, leaving only a faint memory of their presence. The concept of virtual particles challenges the idea of a real void. Imagine an empty universe where all radiation and energy are eliminated. Would you have total nothingness? Quantum field theory says, no. Even in a vacuum, fields would remain active, sometimes creating transient particles. Gravitational waves, ripples in the fabric of spacetime, are typically associated with massive cosmic events like black hole collisions or neutron star mergers. However, some scientists propose that primordial gravitational waves, those originating from the earliest moments of the universe or even from a phase before the Big Bang, could carry the fingerprints of whatever existed prior to that moment of creation. If detected, these ancient waves could offer a direct signal from the pre-Big Bang universe, encoded in the way spacetime itself was stretched and contorted. They could carry patterns, like faint cosmic scars, etched into the universe by the dynamics of inflation or by events that might have occurred in a previous cosmic cycle, if cyclic cosmology holds true. These theories stretch beyond the limits of traditional cosmology, often intersecting with quantum gravity, a field of study that tries to merge quantum mechanics with general relativity. One promising approach in this direction is loop quantum cosmology, LQC, a theory which proposes that the universe didn't begin with a singularity but rather underwent a quantum bounce. In this model, the universe contracts to a minimum size due to quantum effects, then bounces back into expansion, our current universe. This suggests a pre-existing universe that collapsed and transitioned into ours. Another possibility involves string theory, which envisions our universe as a three-dimensional brane floating in higher-dimensional space. In this model, the Big Bang could have been the result of two branes colliding, causing an explosive transfer of energy into our universe. This scenario opens the door to a pre-Big Bang reality where other branes, and possibly other universes, existed and interacted, completely independent of our own timeline. As we push these boundaries, one thing becomes evident: our universe might not be the whole story. It might just be a chapter in an infinite cosmic saga. The concept of eternity, once solely in the realm of philosophy and religion, is now a genuine consideration in physics. A realm where time loops, quantum fields shimmer, and existence itself is fluid and recursive. In the end, the question what came before the Big Bang may never have a singular answer, because time, causality, and existence as we know them may emerge from deeper, unknowable principles. But by asking, by theorizing, by observing faint echoes and cosmic whispers, we edge closer to understanding not just where we came from, but why anything exists at all. Gravitational waves are ripples in spacetime as a result of massive cosmic events. Scientists believe early-stage waves, if ever detected, could reveal insights into the universe's earliest moments. These waves could serve as reminiscences of the past Big Bang. Should they be identified, they could provide evidence of the universe's previous phases. The possibility of discovering gravitational waves in their early stages is one of the most exciting prospects in contemporary cosmology, as it may not only expose the truth regarding the Big Bang but also provide a glimpse of the universe's state prior to the beginning of our known cosmos. This theory presents an enticing prospect, detecting gravitational waves that could act as fingerprints of a pre-Big Bang universe. As we continue to explore what could have existed before the Big Bang, we delve into concepts that test the limits of our comprehension, challenging even our most fundamental presumptions regarding space, time, and existence itself. One of the most mind-boggling ideas comes from the realm of quantum gravity, a field that seeks to merge quantum mechanics with general relativity. This merger may or may not reveal a unified theory of everything and could provide insight into what existed prior to the quantum Big Bang. Quantum gravity suggests that space and time are not smooth, continuous entities as we experience them, but rather hidden granular structures. According to this theory, the space-time fabric itself could have originated from a structure on the microscopic Planck scale, with tiny quantum fluctuations shaping the universe in ways we do not yet comprehend. From this perspective, what we perceive as the smooth continuum of space and time might have emerged from these shifting quantum fields. This leads to the idea that before it was possible to describe the Big Bang, reality could have been radically different, a concept in which time and space themselves lacked completeness. Another possibility is that the universe is part of a vast cosmic landscape filled with potential universes, each with different physical laws and constants. This theory, known as string theory, gives rise to the string landscape, a framework where all fundamental particles are actually tiny strings that vibrate. Within this framework, there are many possible configurations, each representing a distinct set of physical laws. The string landscape suggests that our universe is just one of many, each emerging from its own distinct Big Bang-like event. The existence of such a landscape brings forth the notion that other universes might have different dimensions, different strengths of gravity, or even different types of matter. In this perspective, our universe's matter might not be unique but rather part of a collection of universes called the multiverse, each independently developing. The multiverse theory provides a speculative yet intriguing response to the question of what came before the Big Bang, perhaps another universe in a different configuration, leading to endless cycles of creation and destruction, with no definitive origin. In addition to these cosmological models, some theoretical physicists have also considered the role of black holes in shaping the nature of the universe. One hypothesis gaining attention is that our universe could be the result of a black hole formed in an alternate universe. In this scenario, the singularity at the center of a black hole could serve as a gateway to a different universe, the Big Bang being the moment when such a black hole gave birth to our cosmos. This hypothesis is bolstered by the fact that, according to general relativity, the singularity, a point at the black hole's center, is where space and time curve infinitely, creating an area where the established rules of physics break down. It's possible that the extreme conditions inside black holes may result in the development of new universes, suggesting that what we consider the Big Bang was just the birth of our universe from the singularity of an ancient black hole. Exploring these concepts requires a deep dive into the very nature of time itself. Some cosmologists believe that time, as we understand it, may have had no meaning before the Big Bang. If time began with the Big Bang, then there may have been no before in any conventional sense. This point of view suggests that time itself might have emerged from a quantum fluctuation or from a primordial state where the usual distinctions between past, present, and future did not exist. This could force us to rethink the concept of causality, which relies on the assumption that events happen in a linear sequence. If time did not exist as we experience it, then considering the issue of what preceded the Big Bang becomes nonsensical, as there would be no temporal framework to support it. Theories of cyclic time, as mentioned previously, also contribute to this discourse. Cyclic cosmology posits that the universe undergoes endless cycles of birth, evolution, and eventual collapse. In this model, the Big Bang could represent just the most recent bounce in an eternal series of universe cycles. These cycles might not be identical but could evolve in different directions, each with unique physical properties. From this theory's view, the universe would be a continual process with no true beginning or end, rendering the question of what arose prior to the Big Bang meaningless in the conventional sense. The idea that time itself might be cyclical suggests that every Big Bang could be followed by a contraction and another big crunch, with the universe reinitiating itself in an endless loop. Another avenue of investigation into the potential nature of the cosmos is the idea of a primordial soup of particles and fields that existed prior to the formation of stars and galaxies. This concept suggests that before the universe began its rapid expansion, it was filled with a dense and hot collection of elementary particles, including quarks, leptons, and bosons, all in a state of extreme energy. There would have been interactions between particles at very high temperatures and densities, establishing the foundation for the formation of matter and energy. Some versions of this theory suggest that this primordial soup existed in a quantum foam, where particles constantly emerged and vanished due to the uncertainty principle of quantum mechanics. The properties of this soup could potentially provide an understanding of the universe's beginnings and, by extension, what ultimately preceded the Big Bang. What existed before the Big Bang remains one of the most profound mysteries in science. As our understanding of quantum mechanics, cosmology, and fundamental physics deepens, new theories will continue to appear, offering increasingly complex and occasionally paradoxical explanations for the origins of our universe, an ancestral past we might never fully comprehend. Still, the pursuit of this knowledge will continue to stretch the limits of human curiosity, driving us to explore the unknown, the very boundaries of existence. As we peer further into the cosmic unknown, one thing becomes increasingly clear. Our universe is not only vast in scale but also in the depth of its mysteries. Each theory, whether it involves black holes, quantum fluctuations, or an eternal multiverse, offers only a glimpse, a single perspective in an ever-expanding mosaic of possibilities. Cutting-edge instruments like the James Webb Space Telescope, gravitational wave detectors such as LIGO and Virgo, and future space-based observatories are expected to deepen our understanding. They might one day capture indirect signs of pre-Big Bang conditions or uncover the fingerprints of primordial phenomena embedded in the cosmic microwave background. Yet, as we gather more data and refine our models, we may also encounter more paradoxes, unexpected contradictions that challenge the frameworks we've relied upon for decades. In this sense, science is not a linear path toward ultimate answers but a dynamic dialogue between imagination and evidence. Philosophically, the question of what came before the Big Bang nudges us toward the metaphysical. If time itself began at that singular moment, then asking what happened before may be as meaningless as asking what is north of the North Pole. But even this framing invites deeper inquiry. Is our understanding of time simply too limited to grasp such concepts, or are we brushing up against the edge of knowability? Religious and spiritual interpretations also enter this discourse. Many belief systems see the origin of the universe as a divine act, a creation beyond human comprehension. While science and spirituality often diverge in methodology, they converge in awe. Both grapple with the same fundamental question: why is there something rather than nothing? In the end, the mystery of what preceded the Big Bang might never be fully resolved, and perhaps it doesn't need to be. The journey itself, the quest to explore and understand, may be the most profound expression of human consciousness. It is in this relentless pursuit, through mathematics, observation, philosophy, and reflection, that we find meaning. As we push forward, building bridges between the known and the unknown, we carry with us a quiet truth: the universe may not reveal all its secrets, but it will always inspire us to seek them.